Hey there, welcome back. Some time ago, I posted a video about how to build this fire simulator. It's old school retro fire effect. And I built it using mostly the same graphics functions as what I've been using in the Iron Kernel project. Even the mouse cursor is the same, the color setup is the same. A lot of things are the same. So what I'm going to try to do today is transfer this. It's a C# project. Let's see if we can transfer this from a full screen standalone C# app into an app we can shove into our app launcher in the Iron Kernel system. We're going to do it in C# this time because it's all the code's in C# and it's backed by a pixel buffer that I'm not entirely sure how I want to show that. How do I want to give a pixel buffer to a mini script? So let's dig into this. There's several branches on this project, and the final branch has a lot of mouse interaction and stuff going on. The initial branch is just random fire. It draws some pixels and does some math to make it look like the fire is drifting upward. And we are going for the simple version in this conversion. Okay, so I'm looking through the code here. This is not relevant. Okay. Starting for the program. And yeah, I got the same kind of bootstrapping code, and then almost every program I've written in the last year, which is how I got started trying to write an entire kernel, because I thought, if I have a bootloader, what comes after a bootloader? Well, a bootloader is supposed to boot into a kernel, so what would the kernel look like? And then I got thinking, what would the userland look like on top of the kernel? Onward and upward. Most of this stuff we don't need. You can see parse the command line, and running the game, create the host builder, provide services. There's a standard game engine interface it grabs, and then it runs the main state inside of that game engine. So let's look at main state. This is everything we're going to need for this conversion. And it has some things that we won't need, which is even better. The main thing is just this rendering function, and got some properties that control it. Exposing lots of properties with getters and setters is nice, because those will turn into basically an automatic user interface with the inspector. So that will be kind of a fun thing to demonstrate. Alright, then popping back over to the Iron Kernel project. If we go to the app root, it's like we got a couple of things that look like the entry class. This is what the kernel looks up. An iUser application interface, and this is basically it's another level of bootstrapping. The kernel has its service provider. The userland has a separate service provider. Because a key thing is just trying to keep everything isolated. Isolated, sandboxed. You can't, if you're going through the correct APIs, you can't even access the file system. Not in a normal way. You can only access like a very small piece of it. But the application then switches over to the app root. The purpose of the app root is mostly building the world. And this is one of the things that I want to get scripted soon, because I want there to be a single miniscript file that will set up all these like default toolbar and what applications you have access to and where everything's going to live. yeah, right now if I'm, like I was building a slider control, tested it out by dumping it into the world. But it doesn't need to stay there. So we got the toolbar for the app launcher here. And we are going to add one. Should I stick it in the window? No, I'm not going to put it in the window. It's just going to be what it is. Fire demo. Okay. A window's a strange thing in the Morphic system because, like, in a normal user interface, a window means you have something that you can close, resize, move around. But in Morphic, that is pretty much everything, unless you have a layout control specifically prohibiting it. Okay, so this is where we're starting. Namespace mismatch. Okay. Let's see if I broke it yet. Alright, we have a place we're going to shove the fire demo. When you want to morph to draw itself, like some kind of custom drawing on the morph itself, then you want to work with the draw self method. You can see that the draw method is not overwritable. It's doing a lot of things. It's setting up the transformation and clipping area on the rendering context. It's drawing itself. It's drawing all of its children. And it's making sure nothing stupid happens and all the transformations get popped back off when you're done. This should be relatively straightforward. We need to set up the palette. Let's see, the base doesn't need anything, but you do need to call it. Oh. Let's do this. The morph does not get to own the entire rendering context. It gets to have its own area. But how's that going to interact with the app launcher? Let me think. When the launcher adds an app, it's going to the service container to generate it. That means we need to wire it up in the service container, service provider. And also that it needs a parameterless constructor, which is what's giving me pause right here. Let me think. We're going to give it defaults for now. We're going to come back to this in a moment. So we have the constructor, and then we need all of this stuff. And we're going to skip it's basically debug code. It's not a real user interface. The base draw self shouldn't really do anything, so we don't need to keep that. Render filled rect, bounds, radio color black. It'll be so exciting to see what the performance is like when this is done. Set pixel. Not using, cannot use OpenTK types in here. Kind of, the user land should not know that OpenTK exists at all, because at some point it might not. I'm not committed to sticking with OpenTK long term. There's other libraries we could use, or we could even swap out the whole kernel and maybe stick a real kernel in there. I don't know. I don't know what I'm going to do in the future. Whatever sounds fun. Now, problem here is that we need this to be based off of the actual size of the morph. Let me think for a minute. Can I do that? No. But what we can do, this is what we can do. This is the right way to do it. Because when you change the size, it only sets it if it needs to be set, and then it invalidates the layout, and then it syncs the script state. The script state is how Miniscript knows things about the morph. If C# property is changed, that's pushed down to Miniscript, and if Miniscript changes the value, that's pushed back up into the morph. So all we need to do is set the size and then you do want to call the base update layout here because it will update all of the children. And whether you update the children first or last is kind of dependent on what you are doing with the morph. It's like sometimes you just want the children to reposition themselves based off of what you did to the parent. And sometimes it's like if it's a stack panel, you want the stack panel to change its size based off of what the children need, usually. What we're going to do here, if everything is resized, we need to rebuild this buffer, which means this cannot be read-only anymore. And let's turn these into properties so we have something to play with. And that really only needs to be one blend factor, so we'll do it like that. height. And then theoretically, if we resize the morph, it should change the size of the fire that we're making. Well, let's see if that worked. Okay, look into apps. There's our fire demo. Gonna need to do something so the window will size itself to the contents. So open that, and that's interesting. Why are there two of them? I don't know why we have two of them. Something's not doing what it should, though. Setting should clip the bounds to true means that anytime it tries to draw a pixel outside of its own bounds, that pixel will get clipped off. Okay, so it's only rendering that one thing, but the rendering, there's something weird going on with it. Ooh, now that was weird. I am so curious as to whether you can see where the bug is. Because we should not have to clip to bounds if we're only drawing within the size that we're working with. Because if we do this, that should put a green pixel at the top left of the screen. Or not the top left of the screen, the top left of the morph. But does it? And there it is, right up there. Cute little green pixel. The problem is that that's a rectangle, but the position of that rectangle is the position of the morph, and that's wrong. Okay, I think that will help. Let's find out. You know, that did help. Of course, it's still not, you know, making fire. I'm going to try putting this blend factor back the way it was. Cut back here. Didn't help. Alright, what's going on? It's basically the same code. This one does work, right? So that is what we are aiming for. Same size, 320 by 240. Not that that should matter. Going back to the constructor, create the array, clear it, height, first height, then width. And this function should be exactly the same. It was copied from this project, more or less. I'm going to stick this down here. Make sure that's not being called on each frame, because that would throw some things off. Ooh, what was that? Well, it's mad because that's empty. That was never going to work. I need to do something. It's like, it's a problem in the user land. The exception goes up to the kernel. Kernel's like, well, the one process we're running failed, so we're just going to stop. But an exception in one morph should not bring down the entire system. It should pause the execution of that one morph. So that is going to be on my work in progress list. That's the problem. Update layout is being called over and over and over and over and over. Why? Why? Because that would be a performance problem. Theoretically, update layout should only be called after a call to invalidate layout. And then the invalidation travels up the ownership chain. I feel like that should go there instead of an update. want to solve this. Why is the layout, update layout, being called so often? So, let me see. Oh. Well, I didn't. That's not right. Is that what I copied, though? That's interesting. Moving the mouse is causing the layout to invalidate. I wonder if that's what I want. Is that ever what I want? This might break a lot of things, but let's just see what it looks like. Well, that's not broken. And that's just working. Well, that didn't work. Okay, so that was bad. Need to find it, though. And index was outside the bounds of the array on line 69. This line. What array? Because it didn't fail inside the rendering context, it failed in the draw self call. Let's see that again. Super easy to crash. First error was right there. Index outside the bounds of the array. That is a terrible kind of error. It means almost nothing. Doesn't mean that error, does it? Yeah, that that data field, that's the error. I mean, that's the array that holds the pixel data. But then I mean, there's a little bit of a problem here. Make sure x is in range as far as 0 to width. Y has to be 0 to height. That feels wrong. Oh, no, that is right. Sorry. I mean, technically, we don't need to be rendering a black rectangle there on each frame anyway. We would need it on the first run, or if we made it bigger. I don't know. Let's see if this still crashes. Still crashes. Just went down to the next line. It's like, okay, now actually it's dying there. So here's what we're going to try. Just going to do some bounds checking. And then lots of bounds checking. Get fire, set fire. Okay. Now if you try to access something out of bounds, it should just quietly move on. Or if you try to set something out of bounds. wonder if I'm missing anything else. And there we go. We have a fire morph. One more thing I want to do. Reinsert that blend factor. Now, get an inspector for the fire. Why did it stop? Interesting. That's going to be a bug for another time. Adding the blend factor in the inspector is reflected in the simulation here. I'm not sure why the inspector is... It's probably that same update layout bug. That's what was doing it earlier, because you can see it looks like the fire buffer is being cleared out each time. And... here you just like do this. That's really for one-dimensional arrays. There's ways to resize it and keep all the data, but it's more effort than I want to put into it right now, because we've been talking for 40 minutes almost. So I'm going to leave this demo at that. This is going to get pushed up to GitHub in just a few minutes. My goal for the next video is to demonstrate a method for moving all of the simulation code into Miniscript. It's going to be a bit of a trick. I'm not sure yet how I'm going to do it, so hope to see you again soon. Wish me luck.